So when we're working to find limits using algebra, we're still working with the same features that we were in limits 1, we just can't see them. So we're still going to have times when we're looking for the end behavior, what's happening as x approaches infinity, sometimes when we're approaching a vertical asymptote, sometimes at a jump discontinuity, sometimes at a continuous function where everything's just flowing real smoothly, sometimes at a removable discontinuity. So the way that we approach these is we really are always going to start with all of them by just plugging in the number that we're approaching for x and then see what happens. And what we get is going to tell us which of these features we have and what we would expect our answer to be. It's also going to tell us what methods we should use to solve it. So let's write this down. To determine the limit of a function algebraically, start by plugging in the number x approaches This will tell you what feature, and by that I mean vertical asymptote, jump discontinuity, so on and so forth, the curve has at that value. So when we plug in our number, I'm just going to go through the list of what the results tell us about what we have, and then I'll go through some examples. If the result is a finite number, so that's any number other than infinity, so pi is a finite number. 0 is -1, positive 297 million. Those are all finite numbers. It's just anything not infinity. The function is continuous at that value of x. So the number is the answer. This is true only when we're not working with piecewise functions. With piecewise functions, it's not guaranteed, but we'll talk about them in a little bit. Piecewise functions are just the ones that have the funky squiggly bracket, and so there are different equations for different values of x. Another thing that can happen, if the result is a non-zero number over 0, the function approaches a vertical asymptote like that right up there. And so that means our options are either positive infinity or negative infinity. Or it could be does not exist. That's if they don't match. If the result is 0 over 0, the function has a removable discontinuity. The limit will be a number. This, by the way, is called the indeterminate form. Basically, it's just icky. We have to do some more playing with it, and we'll see how to do that in a while. Then there are a couple of special cases. One is if x approaches infinity. We need special rules to quote-unquote plug in, because we can't really plug in infinity. What that means, though, with the positive or the negative infinity, it means that we're asking what happens as the curve goes off the edge of the graph to the left or to the right. And so it's either going to go up to positive infinity, down to negative infinity, or approach a horizontal asymptote. We're going to do more rules for this in another lesson. And finally, if there is a piecewise function so that's f of x equals, and then like one thing if x is less than a, and then another thing if x is greater than a, is that kind of thing. Then there could be a jump or removable discontinuity if we are finding the limit as x approaches a. So if this number that we're finding the limit at is not the same as the one where we switch from one equation to the other equation, then we could still have some of these other situations going on, but we're only going to have that jump discontinuity at this switch. One thing I want to mention is that these are two special cases where these are going to affect what we do to put in the input. These three are based on what the output is. If we're able to plug in a finite number, what we get out. So these are situations where plugging in is hard. These three situations are based on we plugged in a number, look at what we got. Okay, let's go ahead and take a look at some of these examples. So let's say we're finding the limit as x approaches 0 of x squared. Well, the first thing we're going to try with these, unless we have either infinity here or one of the piecewise functions where we have to do something a little bit different. So we're just going to take this number, we're just going to plop it in here. Because the thing is that a lot of the time what we're dealing with is a continuous function, where whatever x squared is when x equals 0, I mean, that's the limit, that's also the value. So let's see if that works. 0 squared equals 0. This is a finite number. The function is continuous. At x equals 0. Limit is 0. That's all there is to it. let's say we have the limit as x approaches 1 of 1 over x minus 1. So what I'm going to do is I'm just going to start off by trying to plug in this 1 right here. So I'm going to do 1. It's going to give me 1 over 0. So this, looking at what I had over here, it's a non-zero number over 0, so we have a vertical asymptote. So that means the limit is either positive or negative infinity, or does not exist. We're going to go over, again, how to figure out which one of those it is, so that'll be in the next lesson. We could have the limit as x approaches 1 of x squared minus 1 over x minus 1. And so if we do that, if we just pop that 1 in both places, we've got 1 squared minus 1 over 1 minus 1. That's going to give us 0 over 0. That means, if we look back at our little rules, that is the indeterminate form. There's a removable discontinuity. That means the limit is a number. And then something like this, limit as x approaches infinity. I really don't even have to look at what I'm writing here. It could be anything. As soon as I see that, I know that we're in a situation, actually I shouldn't even put the arrow pointing there. I should really put it pointing to over here. Means we're going off the edge. The answer either positive and negative infinity or a horizontal asymptote. And finally, let's say we have the limit as x approaches 4 of f of x, and we're told that f of x equals 2 if x is less than 4 and equals 6x if x is greater than or equal to 4. Notice that these match, so that means there's a potential jump discontinuity. If we were evaluating this or finding the limit at x equals 3 and it wasn't the same number, then we wouldn't have a potential jump discontinuity. There might be something else going on. But it's only because these two match that we have to worry about that.